Hi everyone, my name is Sandhya Kumari, Assistant Professor from the Department of ECE, Sistek, Puttur. So today we are going to learn about the transfer characteristics of linear time invariant system from signal systems and random process. So these are the course objectives of signals and systems, and these are the course outcomes. So before learning about the transfer characteristics of LTI system, we need to learn about the linear system. A system is said to be linear when it satisfies the superposition theorem and homogeneity theorem. Consider two systems with inputs x1 of t and x2 of t and outputs y1 of t and y2 of t. So we can define the output y of t as t of x of t. The transformation of input signal is the output y of t. So you can see the equations t of a1 x1 of t plus a2 x2 of t equals to a1 into t of x1 of t plus a2 t of x2 of t. Next one, linear time invariant system, that is LTI system. A system with linear and time invariant called LTI system. It obeys the principle of superposition and homogeneity theorem. The input and output characteristics doesn't change with respect to time, and the input is delayed by t units, then output also delayed by t units. That is y of t comma t equals to y of t minus t. Next one, linear time variant system. Linear system but time variant called linear time variant system or LTV system. It obeys the principle of superposition and homogeneity theorem. The input and output characteristics change with respect to time, and the input is delayed by t units. Also, the output will not be delayed by t units. That is y of t comma t not equals to y of t minus t. And the LTI system properties or it obeys the commutative property, distributive property, associative property, system with and without memory, invertibility property, causality, stability, and unit step response. So next one, transfer function of an LTI system. So here the function is represented with h of t. Input is x of t and output as y of t. Y of t equals to h of t into x of t. So the first block diagram is representation in time domain. The next one is a representation of frequency domain. Here also we are representing the function with impulse response h of s, input x of s, and output y of s. Where output y of s equals to h of s into x of s. The transfer function defined by Fourier transform or with Laplace transform. So for Laplace transform, the transfer function can be defined as the ratio of output signal to the ratio of to the input signal, that is h of s equals to y of s by x of s, or h of s equals to the L of h of t. It means if you apply Laplace transform to the impulse response in time domain, we can get the Laplace transform h of s. And similar way, if you want h of t, we can apply inverse Laplace transform to h of s. In similar way, the transfer function in Fourier transform can be defined as h of omega equals to y of omega by x of omega, where y of omega is a Fourier transform output signal and x of omega is the Fourier transform input signal. H of omega equals to the Fourier transform of impulse response in time domain. And in similar way, if you want the impulse response in time domain, we can apply inverse Fourier transform to the impulse response of frequency domain. That is h of t equals to f of Fourier inverse of h of omega. Next one, filter characteristics of linear system. The LTI system can act as a filter and you can define it as a frequency selective network. So it's having some frequency components which are amplified and some are attenuated. These filters are usually classified into different types as low pass filter, high pass filter, band pass filter, band elimination filter, band stop filter, or band reject filter. The low pass filter allows only low frequency components and attenuates high frequency components. The high pass filter allows only high frequency components and stops all the low frequency components. In similar manner, band pass filter allows particular band of frequencies and attenuates all other frequencies. Band rejection filter, it rejects a particular band of frequencies and allows the other frequency components. And you can see the different filters. First one is low pass and band pass, high pass, and band stop filters. The concept of convolution in frequency domain, time domain, the convolution theorems. Convolution of signals may be done either in time domain or in frequency domain. So these are the following two theorems of convolution associated with Fourier transforms, that is high time convolution theorem and frequency convolution theorem. And these are the web references. Thank you.